This is Ray Tsang.
Hello, my name is Ray. I'm a developer advocate for the Google Cloud Platform. I'm actually based in New York, and this is my very first time here in Russia, in St. Petersburg.
So be nice, okay? Behave.
Thank you for having me here. And if you have any questions, feel free to contact me on Twitter at Saturnism. And we have Baruch, who probably don't need any introduction. Huh?
I'm Baruch, developer advocate with JFrog. Not my first time in Russia. At Baruch on Twitter, very interesting guy you should follow. Yep.
And you're going to be helping me translate today.
I will do my best. Yeah.
All right, very cool. So
we're going to show you a demo.
Yeah.
Right? We will start with the demo as normal people do.
Yeah, of course. And before I show you what it is, I just talk a little bit about it. It's a guestbook application. This is one of the best applications I can ever write. As you can see,
very well designed. A lot of CSS.
Yeah, it's black and white. As you can see, I'm not a front-end developer, but however, I know back-end. So these are made with microservices. And it's basically, if you type your name and a message, we're gonna store that into the database.
So let me figure it out. Every field on this page is powered by another microservice.
That's pretty much so. Yeah.
That's a great architecture.
Yeah. Even the
very robust.
Even Hello World here is coming from a microservice as well. Yeah. This is how you develop application in 2017.
Docker?
Docker.
Here we go.
Yeah, everything. Oh, nice. What? Oh, they from Docker. Is that why? All right, very good. And just so you know, like what it looks like behind the scenes, we have the front end, the back end. It talks to MySQL and Redis for session replication and all that.
And that's all that for this Hello World thing.
All that to say hello to you and also to take a few messages. And if you ever get to that site, please say something nice.
Okay. So it's actually a guestbook, right? You type your name, you type your message, and then it's got recorded and shown on a screen.
Exactly.
Very useful. Very useful.
But however, as you can see, it does have many services here. 5 different components. You run multiple instances each. Baruch, how many developers do you think would take to deploy this type of architecture?
I don't know. Developers don't do deploy. You need DevOps engineers to deploy.
That's the right answer. You have 0 developers deploying this today. However, I was able to deploy this by myself, actually, pretty easily with Kubernetes. And I actually documented how I'm going to deploy this with the Kubernetes YAML file. Right? So it has all the descriptors on what the deployment should look like. And if I go to a very nice visualization tool here, I should be able to see, there we go, my current deployment. So I'm actually running the Kubernetes cluster on Google Cloud Platform with 5 different nodes. And
you need high availability for this kind of service.
Absolutely. It's high traffic, high throughput.
We cannot allow it to be down. What if people want to put some messages in and it's down?
Please do not DDoS this service right now. And as you can see, all of the services are redundant as well. We're running at least 2 instances each.
Reliability.
Yeah, exactly. And from here, we can also see, the deployments. If you are familiar with Kubernetes, you can see we have 2 backends here. And the green box is a service that's a load balancer. And we actually expose the front end with the public IP as well. So let's go take a look.
Amazing.
Yeah, I know. So it should work.
Okay. I think that's the time to switch to the pre-recorded demo. You have the video?
I thought you got the video. No?
It's your demo, right?
I thought you are supposed to record the video yesterday. No? Do you not have it? Gosh. All right.
Should we call it today?
Yeah. Well, thank you very much for
Sorry,
being
guys,
here.
it didn't work out. We're done.
All right, high five. No.
Okay. All right. Yeah. No, we will do our best to fix it. Right.
Yeah.
You deserve at least our honest attempt to fix it. So let's try to fix it.
So let's look at the error message here. I mean, obviously, I didn't do a good job here. Internal server error.
That's very useful.
Yeah. 500
very
and 404 at the same time. I don't know how that happens.
And null.
And null.
Oh, I know. So for null, I know. I think it's a null pointer exception.
You think so?
Yes.
I don't know, man. Because it's 404 and 500 in the internal server. We're gonna find out pretty soon. But what do people do in this case when your production server has this kind of issue? Somebody calls you in the middle of the night. You're like, I don't know. What do you do?
I panic usually.
I'm happy I'm not you. Yeah. Well, there's a couple of things that people do. Well, I have done production troubleshooting for a long time. One of the first questions I ask, well, the logs, and also, can I reproduce this? Can I actually reproduce this in a different environment?
You are a veteran DevOps engineer, right? You should have a staging environment. Do you have a staging environment?
I do have a staging environment for backup. So in Kubernetes, there's a concept called namespaces. So we actually created a separate namespace for my other environment. There we go. Typically, you can put non-prod and prod in a separate cluster, but all the non-prod can go into different namespaces, for example. But in this demo, I just have a staging environment, right? So I can actually go get my service directly from staging. So it's -n for namespace and staging. And I have an IP here that is different from my production IP here. So let's go take a look if that works.
Google. It works.
Wait, what is going on? Maybe my production doesn't work either.
That's because you are in Google. It shows you Google. I think that's pretty cool.
What is going on here? All right. So let's take a look here and let's see get pod. And
what's that?
So if your app doesn't even come up when you see kubectl get pod, you're going to see the status here that will tell you why your application didn't come up. And I think the reason why it doesn't come up is because I'm pulling the images from your Artifactory. No. No, I'm just kidding. Maybe there's a misconfiguration. So no, it's just bad luck today. But however, if it worked, we will probably see it work because, why wouldn't the staging work? Would you ever?
No, absolutely. Yeah. Why wouldn't it work?
Why wouldn't it work except for today? But the thing is, staging, of course, should always work except for today. Because you will never push something to production unless it works on staging.
Oh, absolutely, never. Yeah. Okay, you know what? Let's try to see how we build this image. Okay, let's go to the basics and let's try to examine the image.
Yeah.
Okay, so how did you build it?
So it was built through Jenkins, and I know I deployed it. Let me see what how I deployed it. So if I go to my UI deployment, right? So let's look at the front end again, and we are pulling from. It is pulling from your doc.
Okay, so this part works.
Yes.
Okay, good. We're getting somewhere.
All right, and then I'm pulling this image here from your
Which version?
Latest, of course.
Latest,
yeah. We're doing CI/CD.
Very useful. Which version is it? In numbers?
Latest, of course.
Yeah. That very useful.
CI/CD, continuous delivery. No,
that's great. Okay, so how can you find latest image?
I don't know. Yeah, the latest on your machine could be different from my machine, right?
And
or
usually
on your
is.
machines. Yeah,
right.
Okay.
Can we do Docker inspect on it?
Yeah.
Or the Kubernetes?
Actually, we can. So
describe. Yep.
Yeah. So in Kubernetes, if you know the name of the pod, the instance that we're looking at, we can do a kubectl describe the pod, and that's going to tell you most of the metadata about what is actually running there.
Oh, here you go. Now we're getting somewhere. So here we have identifiers, which actually not latest, and can give us some numbers. So for example, yes, this one. That's the container ID. We have an image ID.
Okay.
So let's take a look at the image.
Okay.
So we can take this SHA-2, right, this fingerprinting, and take it to your registry, which in our case is JFrog Artifactory, and run a checksum search.
Okay.
Let's see if you can find.
Do we do the checksum?
Yep. Right, let's see if you can find it.
Okay.
Oh, here you go. Oh. Okay, now we are in much better state because we actually know the version. The latest correlates to version number 50. So we can go and look at it.
Okay, how do I do that?
Yeah, then you are in the right place. Okay. And here we can start examining it. So we can go to Docker info and see what's going on here.
Okay.
Let's take a look. Okay. Is there something maybe in the command that you run in the entry point?
I have no idea. You can actually see here. Yeah. Oh, wow, that's interesting.
Okay, it's Java. It was null pointer exception. I knew it.
Of course, any Java application could have thrown out. Yeah. Okay.
Something looks fishy here.
No.
What is this app.jar? Can we get to it maybe? Do we know what app.jar is?
Again, that's not version, is it?
Oh, you're just great. Okay.
Continuous delivery. Okay.
Let's open this latest and look at the manifest for a second.
Manifest JSON.
Okay, you should have here the build tab after the properties, right? The builds, and it will actually show us how it was built. So first of all, you can go to your Jenkins right from here.
Okay.
And see maybe it's something in the commit, maybe some commit that you did actually ruined it.
Yeah.
Let's see if your Jenkins is up.
If your Jenkins is up.
It's your Jenkins, not mine.
It could be mine.
Okay, all right. Okay,
so
let's.
Jenkins is also down.
No worries.
Today.
Jenkins is down. Everything is on fire. But we are fine.
This demo is not going so well today.
We are just fine.
Yeah.
Okay. Let's go to the build and look at it first.
Okay.
So here we have some more information. Yeah, it was Jenkins.
Wait,
who is Mark?
Who built this app?
Tons of people have apparently. Tons of people have some production access here.
All right.
We don't know who Mark is. We've never met him. Okay.
Right.
You know what? Let's take a look at the published modules.
Okay.
Maybe we can find this Java thing. Oh, here you go.
Okay.
All right. Cool. We have some Java snapshots here.
Yeah.
Take a look at which one do we need? The UI,
the
right?
UI,
that's
the one. Oh, I can click into it?
Oh, here's the jar. Now we know which jar it is.
Okay.
So we can actually go to jar and take a look at it.
I can? Wow.
Right.
Full traceability here.
Yep. So something here. Mark, this guy Mark again.
Still deployed by Mark, yeah. That's
Okay, so we can blame it on Mark and call it a day? Can we do that?
yeah, sure. No, but my production issue is still there. Let me double check here. Does this still work? No, that's not
that was Jenkins down, this was staging down, and this is the production down.
Right, okay, that's not helping us.
At least consistency. Everything is down.
Yeah.
Okay, good.
And no blames here.
No, Mark is just fine.
Yeah. All right, okay, so
you can take the previous jar if you want and try to deploy it instead.
Yeah, we could possibly do that, yeah. Right. And then we can check if the application is still working, and
after you fix your Jenkins, we could go to the source from there and check that maybe something is wrong with the source.
Yeah, but if it still works perfectly in your dev environment, of course it does, right? But it
everything
still
works
in production.
Yeah. You want to try and debug production?
What do we do next? Yeah, so what do we do next? If you verified the app in other places, you don't know what the user has done, you just want to kind of figure out, okay, what exactly is happening, what do you do next?
What do you do first thing? You're waked up at 3 in the morning. What do? You remember, right? You were in my talk with Leonid. What do you do?
What did you do? Have a drink?
Logs! Right.
Logs.
No one said it, but yes, you look at the logs.
Logs, okay. So in Kubernetes, there's actually a really, really easy way to get to the logs. So we're talking about the UI instances here, and there's a really handy command line called kubectl logs, and you can actually follow the logs as well. And now you gotta pick one of these logs to see. Now, having 2 instances, what are the odds for me to see this error?
With 50%, whether you see it or not.
50%. But what if you're doing microservices, right? You could have easily done something like this, where you have the Hello World UI is just so great, you need more instances.
Yes.
And you have 10 instances of them.
Great.
Yeah. And now what do? Now you can actually see all the instances popping up.
Still 50%, either you see it or not.
No, now it's 1 in 10. Now you have 1 in 10 shot. But
you're good in math.
Yeah, thank you. I try. This one's easy. But we could actually try to find one, right? So if I go there,
it just took a random one. Good job. This is how we do it.
Oh, dude, I found the error.
Wow, 1 in 10.
I need to go buy some lottery.
Yeah, you need to buy some lottery today.
Yeah. But I can scroll up, I can see all these. But of course, it's not exactly useful when you don't know exactly which pod or which instance may have the issue. Now in Kubernetes, usually what people do is that they can deploy some kind of log aggregation. So if you're running this on-prem, you can run something like Elk. You can have Elasticsearch and Logstash and Kibana. You can actually centralize logging, and you can go in and search it. I happen to be running this on Google Cloud. What that means is we already, out of the box, perform the centralized logging function for you, and all of the logs are automatically forwarded if you output it to standard out. We automatically forward it into what we call stat driver logging. And from here, we can actually,
And this is aggregated. So here you don't need to guess which pod you are into,
Yeah.
it will show you everything.
Exactly. So we can find the cluster. I got multiple clusters running. I can go into the right namespace. If I want to see what's wrong with staging, I can go there. But we can go to default. That's the namespace I'm running
Who
on.
cares about staging? We have production down.
Yeah, exactly. We're straight to production. And then here we can also see the different deployments, the different applications. So we can go just narrow this down to Hello World UI. But we got so many entries here. Maybe you know some kind of, you're looking for exception. You can do a little search.
Yeah, null pointer exception. I'm telling you, safe bet.
Yeah, you think so?
Yeah.
Yeah, I don't know. Is it really MPE or how
Null pointer exception. Don't be lazy.
I have to type it out. No, I guess not.
Huh.
I guess not.
Look at that.
Yeah,
It's Java and it failed on something else than null pointer. Weird.
Yeah, well, we're going to find out pretty soon. So here we should be able to, there we go. We got the 404s. There we go. Where did it go? There we go, 404s. Oh, it's client error exception that has a 404 null.
404 null. Yeah. That's a very useful message.
That's still not exactly used. Yeah, I don't know what to do from here. I mean, it's happening from Spring application, and that's like multiple layers of interaction, and I don't know what to do next. But I remember in my troubleshooting days, I used to work at a large hotel company, and I do get a call at 1 a.m. in the morning. And the first thing I would need to do was actually to narrow down this issue to see also if this is happening on just one instance, or is it happening across the board? Because if it's happening on one instance, maybe I can do something to fix it.
That's easy. You just kill it.
Yeah, yeah. If your instance is running, well, you just kill it. No, I don't think we should be doing that.
I mean, it's cattle against pets, all that. We can always kill an instance, and Kubernetes will fire up a new one for us.
You can, but then the problem with that is potentially, what if the issue comes back tomorrow, or what if it comes back, a week later?
It's 3 a.m. You really want to get to bed? Just kill it and go get back to bed.
No. Well, unless it's a weekend, yeah, sure. Do you know anybody who kills their JVM every week, just so?
Absolutely. Yeah. When the best way to prevent out-of-memory errors in Java is set up a cron job that will restart the JVM every week.
I do know people who try to fail the Kubernetes health check every week just so Kubernetes can automatically restart their JVM.
Here you go.
Yeah, that's bad. Don't do it.
Universal battle-proven practices.
Yeah, definitely do not do it. Well, what we can actually do is, what I used to do is I need to log into all the boxes. I got to do SCP, copy all the logs out. They're like gigabytes large. And then I need to aggregate them myself and maybe run some kind of Perl script or grep, and then maybe dump it into HBase and run a pig script, whatever. Trying to figure out what is wrong with the application, if it's abroad or if it's like just narrow.
How do you reproduce this thing?
So we can't. What we can do here though is we can actually export the log directly into different what we call sinks. And what that means is potentially we can we can send it to PubSub. That's a messaging system, so you can actually do real-time analysis on all the incoming log messages that you want to narrow down.
That's kind of it can be used as monitoring, for example.
Exactly. Or if you want long-term storage, you can store that in our bucket storage. But my favorite is this one, which is BigQuery. So we actually dump data to BigQuery, and what that means is rather than just doing a full text search, you can actually do queried structure search directly against your logs, and that's really cool. So if I can go into, say, BigQuery, where did it go? BigQuery, there we go. And we actually automatically create the logging tables for you, and we exported this to the Hello World UI. There we go. And for every day that this has the data, we actually created a table for you. So this is sequenced with the different dates. And here's the structure of it. So we can actually query it to kind of ask questions so we can get answer. So I'm going to open up a log, a query here. Just
so we still try to understand whether it happens on one instance or many, right?
Exactly,
yep.
Exactly. So let me go to not that one. Let me find a query that is somewhat readable for me. Oh, wow. What are these queries? Where did that come from?
Mark.
Yeah. Where is Mark? We need him in this demo. All right, here we go. I'm going to open up this query. So this is just a standard SQL query. What this is doing is, let me query against the logs with the resource type of container. with the name of my app. And I'm just going to be looking for exceptions. I'm going to be grouping this by the name. And I'm going to sort it by the occurrences from today.
Limit 1,000 is very modest. It's a Java application.
Just in case we have
Java application running in Docker.
Yeah.
I mean, we didn't even start with 1,000.
Yeah, but we only have 2 pods now, but we only have, one of them does have a lot more issue. You can also query across the entire date range or for the duration of all the logs, and you can just put in a star, then you can query a lot of logs. I personally done this in the company to troubleshoot our issues as well. But it does look like this one has an issue. Let's go take a look.
Both of them have issues, but again, it's a Java app. 20 exceptions we can safely disregard. It's almost like no exceptions at all. 50, it's a different story.
Yeah, you gotta set a threshold somewhere.
Yeah.
So where is that one? That's the one ending in what is it? K9 blah blah blah. Oh, there it is. That's the one.
Yeah, that's the one.
What should we do?
I told you, kill it.
No. No. Let's not do that for now. What we can actually do in Kubernetes is that every one of these pods.
Okay, so at least let's take it out of service if you don't want to kill it.
Yes. So every one of these pods, every one of these instances are actually associated with a label. Okay. So the labels is a very important concept in Kubernetes. You can label just about anything that you want. And for the load balancer, for the service, we are routing the traffic to individual instances based on the label.
So this label is just a free text. You can label whatever you want with whatever you want.
Exactly.
But then other services can rely on those labels as a convention to do funny stuff with it.
Exactly. And the funny stuff that we can do here is that I have a label called serving. And I'm only routing the traffic to any of the instances with the label of serving is set to true. What that also means is I can actually take this individual instance out of service and troubleshoot it right there and there. And if this is the actual instance that's causing trouble, it wouldn't cause trouble anymore. So we can give that a try. And the way we can do it is by override. So we can use the command line here called kubectl label. We can override the label for a pod, and we can just set it to false.
Serving false.
Yeah.
Here you go.
And now, what is really cool is we took one instance out of service. Okay. So you can see that this is false now. What that means is no more traffic is going there. However, because this is false, we still have, actually, if you count it, we still have 10 instances in total.
So now we have 11. One of them is decommissioned and 10 live. Because you remember, this guestbook app, we have to have 10 live instances for it, right?
Yeah, just so everybody here can use it.
Yeah.
And however, though, the reason why one more instance got started is because Kubernetes recognized that one of the instances is out of service, and based on the labels, it needed to start another one to replace it. So you can actually see this new instance that's only started for about 30 seconds or so. Okay? Because now we have isolated this instance. What we can do
kill
is no. Not yet. We can do a few things. We can, of course, go into it. So we can do kubectl exec, right? So we can get a bash shell here. And what that means is we can kill not 9.
Yes.
No.
Yes.
No.
Yes.
How do you do the thread dump? Is it kill 7?
Yeah, it's kill
3? I forgot.
Kill 3.
Yeah, something like that. Yeah. Right? So you can do a PS whatever, and then you can say kill 3. Is it gonna kill it? I don't know. Whatever. I did kill it.
Yay!
Not yet. So hopefully that'll give me the thread dump, and you can do more troubleshooting. But if you're in a Java app, or maybe your app exposes additional management console functionalities, for example, in Java, maybe you have JMX, you want to go into JMX, what you can actually do...
I know what you can do.
Yeah?
You can get into it, open this jar with unzip, and replace some class files.
You can also, don't do that. These are supposed to be immutable, but yes, that's possible. But what you can actually do is you can pull forward. What that means is if you want to troubleshoot this particular instance, I can create a pull forward tunnel directly from my machine to the target instance machine. And now, did I not spell this correctly? Forward, there you go. And now I have a secure tunnel that's established on my laptop on port 9080, and that will forward me only to that particular instance. This is really, really handy to troubleshoot a particular instance. So let's see if that works. Oh,
It works. Look at that.
And who is Rick? That's the same.
I think it's friend of Mark.
Okay.
Oh, I know what now all we need to do is just open your machine and start serving the calls for everybody.
Yeah, and I can do that with
Can we do that?
No. That wouldn't be enough to serve all the audience here.
Right, we need at least 10 instances.
Yeah, exactly. So what can we do? So now this is working. We established, we tried to troubleshoot this one instance. We thought this was having the issue, and it's working fine. We have two choices. We can put it back into service, for example, by simply overwrite this serving flag to true, and that will be putting back to the pool. But now you would have 11 instances, and Kubernetes only wants 10, so it will have to kill one of the instances. Yeah, I know.
Random one, right? It makes it even better.
Well, it's not exactly random, actually. I hate to say it, but there's a heuristic behind it. It tends to keep the oldest running instances up because it's most likely to be working fine, but the newest instance is gonna be terminated.
So this poor service that it only instantiated 3 minutes ago, it killed it.
Yeah.
Instead of killing the bad one that I suggest you all along.
Well, we didn't know that was a bad one, and it was not exactly the bad one, so we didn't know. Yeah, but you can also just take it off instance.
It still doesn't work, by the way.
No, I know. Yeah, so it's a bigger issue. I'm running out of ideas. What do you do then?
Okay, I know. We need to connect a real live debugging to production.
Yeah, you think so?
Yes.
We can actually do that.
That's what we do, right?
Yeah. And how much time do we have, by the way?
We have 20 minutes.
We got 20 minutes. All right. So what we can do here is a couple of things. In that JFrog thingy, I've not Bank of America. In the JFrog console, when we see the entry point, right?
Right.
I don't know if you remember, we had the Java jar start, and we actually put in a little agent in there. That agent is actually a cloud debugging agent. And it's
You can show it.
Yeah, and it's a very similar agent that we actually use in Google in our production environment as well. And what that agent can do is to allow you to live debug your application. So I'll show you what that agent looks like.
Yep.
Yeah.
So let's go to that.
Oh.
It will be our local Docker repository. Here you go. And which one of them is ours?
Definitely not pizza.
No, not pizza. Not pizza?
No.
Okay, so let's...
Yeah. Can you find?
Of course I can find it. Let's see which one of those is ours. If it's not released, it should be dev, right? Doesn't make sense?
Baruch, yeah, there you go.
Here you go.
That's it. Yeah,
and
hello,
UI,
yeah, there you go.
right? And we can pick any of those. They're all the same.
50, yeah.
They're all the same.
Really?
Docker info. I hope so. And here you go.
There you go. See, so we put in this little agent in the Java application. What that allows us to do is to actually give you capabilities to troubleshoot and debug your application live. Now, how many people here actually want to do one thing? One is to see inside of the application with the real debugger and see the traffic flow and just see what's going on the line of code. But you cannot really do that with a Java debugger by default. Why? Because it will actually stop the world. And your user would just be waiting for you to step through all the lines of code.
That sounds like fun.
Yeah, yeah. But what we can actually do is tons better. Our debugging agent can do live debugging without stopping traffic and also without any overhead, actually. So let's go there right now. Let's go to debug.
Nothing happens without any overhead.
It's a very limited, small overhead.
Okay, that sounds better.
All right, there you go. Thanks for keeping me honest. And here, because we actually are running the debugger, and also our application has a git.property files inside, what that means is we can actually reference to the actual source code. Hey, Baruch, that's your code. I'm just saying.
It's Mark.
Yeah, it's Mark. And that's actually going to automatically pull down the code in this case because my GitHub is public. And we can actually browse the code here. And this is the UI, right? So let me zoom in a little bit. And this is the root, the index file, right?
All right, okay, that's code that even I can understand. Okay.
Yeah.
And if we check if it's named, then model have an attribute, and yeah.
So what we can do here is let's add what we call a snapshot. So we can actually put a snapshot here.
So it's like a breakpoint, but it actually doesn't break anything.
Exactly. And by the way, this is applied now instantly to all of the 10 instances that's running, and anybody that goes through the code right now, somebody did. Somebody just said hello. right? And
our app is super popular.
yeah, I know.
There's a huge traffic going on.
Yeah, and you can actually see the code stack, which is nice. You can also see the variables that's happening in here, so you can see hello with the
everything
endpoint.
looks good so far.
Yeah, everything looks good. But if I were to go there, probably this still doesn't work. At this point, we may be able to figure out what's wrong from these code stacks, but sometimes I just wish we have more log, right? Because that 500 error, 404 null, that's not exactly useful. What do you usually do when you need to add a new log?
Oh, that's very simple. I go to the source code, I add my log, I run a new build, I deploy a new version in production. In 6 months, you will have better logging.
6 months. or after like 5 hours, you do a hot deploy, and then somebody's really mad at you because you needed to do it. And then what if the log wasn't enough?
You do it over again.
Yeah, do it over again, right? And not only that, you have to check out the right code. You got to check out the right version so that you don't push unnecessary things into production. With the same debugger agent, not only can we do live debugging with a snapshot, we can also just add logs directly. So I just switch over to log point, right? I can say, for example, here. No, maybe here. Let me add a new log. So let me do a cancel here. So I'm going to add a new log here, right? So I'm going to say the name is, we can put in an expression name. Okay? Then I can just add the log message there. This is what people usually do with troubleshooting, right? With the log, they say, step 1, I'm here, right?
That's the bugging we're all deserve.
There you go. Yeah, step 2, I'm here, right? And then, again, in real time, now all of these log messages are automatically applied to the running application. What that means is...
You know how you really should log it?
Well,
JavaScript alert.
Yes, JavaScript. No, that's fine. Yeah, that wouldn't be attacking the console. That should be okay.
Okay.
Yeah. But let's see here. If we do a refresh, I'm generating the log. The lines are going through here. And let's see. So we can go back to the logging console because we don't know which instance got it.
And
right?
see the aggregated log with our new messages.
Yeah. So where should it be? Oh, there we go. Right, so here's the log point, right? So we should be seeing log point 1, I'm here, right? And then there's another one, log point 2.
We never got to log point 2.
Oh, we never got there. But look at this, log point name is empty. So it's a user error.
It's always a user error.
The user did not put in the name. I wonder who that user was. Obviously me, but
Mark.
Yeah, it's Mark, right? So now we can tell very, very easily exactly what happened in the code. And now you establish the fact that maybe you need more logging. You can put the log back into your code for good if you want to, right? But this is a really, really easy and necessary way to help you identify what is wrong.
So how do we fix it? How about the new browser tab? That always works.
No, actually, not a new browser tab because that will still be using the session.
Incognito.
There we go. Yeah. So if I open a new session to validate this, and if my internet works, and if the app is still working, and that nobody DDoSed it, that should still work.
We have 10 instances. Come on.
I know. Yeah. I don't know if my internet is just not there or what happened.
Okay. Let's assume it actually works.
Yeah. What is going on here?
By the end of this session, we were supposed to fix the demo.
Yeah. Oh, but you know what? One more thing that we can do is that because it is microservice, we do have multiple layers for this very simple app, unfortunately. What you actually need is a way of visibility into what all the calls are making. Like, I'm making from the UI to different service calls. Are they all going through? Are they having the right latency? Are they too slow? Are they too fast? I remember that I used to work in consulting, and what happened about 10 years ago in a SOA, in a service-oriented architecture deployment, my first manager said, right, before you deploy this into production, make sure you have a unique request ID that you pass down to all the services call. I'm like, why do we need to do that? Well, for two things. One, you want to have a log on the start time and the end time, right, for every of the calls, so that when something happens, we can actually go back to the customer and say, it is not our fault. That's how you used to work in consulting, right? But no, that's not what you want it for real. But here, though, we can actually see, for example, all the different traces, all of the different layers of codes that actually happened.
Okay, what do you do when the cloud platform is down? When do you
There we go. Holy, somebody is actually DDoSing me.
Yes, look
I can definitely see that.
Okay, let's increase it to 100 instances.
I think we may actually have to do that. Yeah, and that's easily done. But here you go. You can see that the message, the code came in. You can actually trace it all the way through to the very last one. And yeah. And one of them, there's so many. Who DDoS me? I just wondering. Like
Mark.
Yeah. There you go. Oh wow, somebody is actually adding a lot of messages, and one of them, some of them, you can actually see the status code to be 404, and you can actually figure out there was something wrong with the connectivities of your microservices as well.
So is it up? Check the tab. Check the other
where?
tab.
Where? What?
Check the other window.
Well, which one? This one?
Yeah, maybe went through eventually.
Oh, the guest.
You closed it?
I closed it. Yeah, I closed it.
Okay, now
yeah.
let's try.
Yeah, but that's
let
okay.
it run.
Yeah.
Yep.
But also the other thing that we can do is to actually, because we record all the latency, we can actually build automatically reports. What that means is you can actually compare the percentiles in latency distribution from now versus maybe a week ago. So if you do like a new deployment or something like a couple of days ago, and that actually changed the latency distribution, we can actually automatically detect it and let you know that something has gone wrong and you have a performance regression. So that's also really, really useful.
Right. Yep. So any luck with our DDoS?
Oh, there we go.
Here we go.
Oh, nice hat. Yeah.
Yeah. Thank you. Yeah. So we have tons of people participating. That's that's Russian.
Yeah. Not bad. Oh, hey, look who did that. There's always someone. There's always someone.
This is good.
anonymous person. All right.
Yeah,
fair
that
enough.
was Mark.
Who is Mark? Who is Mark? All right. So we got through quite a bit of things. I don't know how much time we have, but let's
10 minutes.
10 minutes. Let's close this up. So we saw quite a few things. We can do log aggregation at scale, and if you're running on-prem, you should definitely look into something like an Alk stack, right? So you can get aggregated logging. We can do metrics, and we can query the logs. You saw that. Oh, this is kind of neat. If you do actually output the logs into the aggregated logging that we have, we can automatically detect frequently occurring errors like that. So we can actually alert you as well, and you can see the distribution of how often the error happened, and you can see where that came from. We can do even more. We can actually click on the button, and we go straight potentially into
the distributions of the pods.
Yes, we can actually go to the log directly. All right, there we go. So that one, we can go straight to the log. This is usually what people do. Like, I don't know what it is. You can mute it, and it's just gone.
Yeah, that's how you should treat errors in your log, right?
Yeah, don't do that. But you can also add the issue list. Yeah, you can also add a list issue to link to the bug as well. So that's pretty useful. And if you're running on-prem, also, if you want to get visibility into your microservices, here we are using Google. We have Dapper, and we actually have the backend for it. But if you're on-prem, if you want to use it yourself, you can run Zipkin. I don't know if anyone went to the Zipkin session. That was really awesome, right? So you should run Zipkin locally or in your on-prem cluster as well. That works perfectly well. If you want to manage instance, you can run it on Stackdriver Trace. You can get all of these awesome things.
Yeah, we saw all of that.
Yeah. Okay, so with all that being said, just remember to debug and troubleshoot your applications in Kubernetes, there are quite a few command line tools that you can use. We saw how to see logs, exec, pull forwarding. That's all really useful. If you need to have more capabilities, you can try some of these other things. And with all that being said, thank you very much for your time.
We have some time for questions.
Yeah.
Thank you, Ray.
Thank you. The source code is on my GitHub as well.
Yep.
All right. So.
Окей. Кто хочет задать вопрос? Что стеснительные все.
Yeah.
Ребят, ну решайте.
Here we go.
Yeah.
We have questions.
Потеряла?
Thank you for your talk. One question, how did you do that logging stuff? I mean, it's really interesting. I mean, You updated on the fly. It was hot
Java
load. Was it rebuilt from scratch and new image? How does it work?
Yeah, so it's using the JVTI agent. So it is the agent that we added to the Java startup command line. Yeah, that thing right there. That little agent that you attach to your JVM that allows you to do live debugging with the snapshot and also log point. That's what we call it. So it literally intercepts or understands where to insert the code to produce the log. But you saw that we can actually do expressions. So with the expression, you can actually navigate your POJO, your object tree, and get to the right field.
So logs look awesome at live demos, but I guess the expressions are more useful when you try to troubleshoot something in production.
Exactly. However, with the expression that we added with the little curly braces, one thing that's really interesting is we actually make sure whatever expression that you add does not actually modify the running state of the application. That's very important because if you're modifying the state through one of these things, you're effectively updating production, right?
Which is great.
Well, no, man, you're giving all the bad advice here. Kill the pod all the time. And no, so we actually make sure it doesn't actually modify the state, which is really
that's
cool.
a shame.
Yeah. So no hot patches here. Yeah.
All right, I tried.
And can you do this real-time awesome logging thing with something else like Python or Ruby or something else?
Great question. So there is debugging support, very similar things with the same features for Python and Go, and I believe Ruby recently as well. Yeah, at least in beta.
But you really only need it with Java, obviously.
But if you ever do a serverless with functions with JavaScript, how do people troubleshoot JavaScript?
Oh, they don't.
Yeah, they do console.log, right?
Yeah, alert.
Alert.
JavaScript alert.
Yeah, I'm here, alert. No, so you can actually do debugging directly with a function in JavaScript, but you do need to do this in function, so in our serverless platform. For the debugging agent that I just showed, you can actually run it anywhere. So you can run this on your own box. You can run it on another on-prem, for example, or another cloud, starts with the A, doesn't matter. Like, you can actually run the agent from anywhere.
Yep.
Yeah. Cool.
Окей, кто-нибудь еще?
More questions? Here you go.
There's one.
Here you go. You can always count on Slava.
Hi, thank you. Sorry, I missed where do the debugger got the source code?
Yeah, very good question.
The tag.
Yeah. So for the debugger, if I go to debug here, 1 second. All right. So there are a couple of ways for you to do it. If this is a public project on GitHub, I simply just use GitHub properties. I added it into a jar, and it automatically picks up the URL for my repository and
So
also the hash, the Git hash.
There is a properties file in the jar file that Google Cloud Platform knows how to find.
Yeah. However, of course, your application is probably not in public GitHub, so you can actually attach source code in different ways. So here you can actually do add source code. You can check in the source code into our repository, or you can synchronize it with your own GitHub repository or Bitbucket, right, with the private. Or you can just upload for the purpose of debugging for just this one time. You can just upload the code as is for this one.
Can I send
one
it
shot.
by email as an attachment?
You can send it to me via Hangout, yeah, or a public.
I use
Google,
Gmail. I'm legit.
Do you use a Google Plus? Because you can post it there too. Yeah.
I don't know if anyone will ever see it there.
No, well, that's safe for you. Yeah.
That's true.
But one more thing that we can do is you can actually run the debugging plugin on IntelliJ. So you can just use your source code locally, and we can still do the same debugging in IntelliJ IDE.
And you will actually have the experience of IntelliJ Debugger, but it will be actually on the live production code without stopping the world.
That is exactly right. Yeah. Yeah.
This is very cool, by the way.
It is freaking awesome. Yeah.
A question from a Java guy.
Welcome.
Okay.
Who is Mark?
Does this work on Java 9? I mean, hot reload.
Oh, I haven't given it a try yet. I should give it a try, but it should, but I haven't tried it yet. Yeah, we should try it.
No one uses Java 9 yet. Not really.
Well, that too.
I do.
Let me see here. So let me see if I got source code here. I don't have source code for this one, but this is actually Java 9 running in Google Cloud right now with a custom runtime. So if I had the source, I'll be curious to see if I can troubleshoot it.
Yeah, it should probably work. There is nothing. What is your like? Why do you suspect it won't work? It should work.
Because it's Java 9, nothing works.
Except of that reason. Any other reason?
Yeah, I'm curious to find out. I'll find out later and let you know. Yeah.
Okay.
Okay.
Any more?
Есть еще время для одного вопроса.
Yeah. So,
Okay, so I'll tell you what. You will have a longer break, but you remember that you do have a job in this break. You should get drunk before the keynote. I kid you not. What you are going to see after the break, you won't be able to unsee it. So it's better for you to get drunk now. There is slight chance that you won't remember it afterwards. That's the only way.